All right, hello there and welcome back. In the previous video, we spoke about the vector table and we saw some of the very important interrupt requests or service routines that were implemented by default. In this video, I just want us to take a look at some of the things we can do to trigger these interrupt service routines to respond, right? And the one that we are targeting particularly is, let's go here and let's look for the hard fault. Okay, so all classes of faults. This hard fault here is the interrupt service routine that gets executed for all manner of faults. So it's the kind of catch-all error type situation. Okay, when everything else fails, you are certain that the hard fault is going to catch if you do anything wrong in your code. Remember from the previous two episodes that I mentioned that there are two kinds of interrupts: the external ones that comes from stuff like GPIO pins, and there's the internal one that is generated from software. All right, so let's try to do something horrible, something bad in code, and let's see if we will be able to trigger, because this is a catch-all. So it's an interrupt service routine for all classes of faults. So let's do something we are not allowed to do, and let's see if this is gonna kick in. So here I have a very bad thing I want to do in code. I have this volatile uint32 type pointer address, and then what I'm essentially doing is, this is a memory, some random memory address I want to access. The address is 00000000001, and I'm converting that into an integer pointer because addresses are just pointers, right? And then I'm dereferencing, so what means I'm accessing the actual memory. I'm not accessing the memory address. I assume that you know about pointers. And I'm trying to store this value, the dead beef, and it's a valid number in hexadecimal, right? So I have some address and I want to store some value there. The problem with this is, in your microcontroller, so come here, you can see how the addresses increase. It's in multiples of 4, so 0, 4, 8, because it's a 32-bit microcontroller. So the addresses increase in multiples of 4, because 1 byte times 4 is what's going to give you 32 bits, right? So it is not possible to access a memory address that is not on the boundary of 4. So I am saying, instead of 0000000, I want to write some value to 00001. It's not allowed because I'm going to corrupt what I'm setting up, what has been set up for the stack pointer anyway. So the processor is smart enough to see that, hey, this guy is trying to access memory in a way that is not allowed, and it has to throw an error, or some interrupt service routine has to respond to that. And as we saw here, the hard fault is for all classes. So let's compile this program, and then instead of running it, because I'm not going to run it, if I do run it, I'm putting the processor in a panic mode. So I'm going to debug so that we can do step by step. And again, I'm going to promise you we will have a dedicated episode on how to debug your firmware using the Cube IDE. Okay, all right, so I'm in debug view now. When you click on the debug button, the program starts, the reset handler starts executing. When it finishes, it calls main and it pauses right on the first instruction. waiting for you to actually click something to get that instruction executed. Forget about all these things here, but these are tools that helps when you are debugging. So I just click disassembly. It's showing the assembly version of the line or the code that we are executing, right? Now, to execute the current line where the breakpoint is, you click the step over. If you click step into it, if it's a function, it will go in and execute it line by line. But because this is not a video on debugging, I'm going to use step over. So what it means is that I have executed this line. This line has no effect. I'm just declaring a variable and storing some invalid memory address there. It's not a problem. The problem happens when I try to write a value, okay, to that invalid memory address. So I click this, and then now it gets to the while loop, and then I click again and see where the processor jumps to. It has jumped to the HardFault Handler, because as we saw from the documentation, this is the handler that catches all kinds of faults. So when everything else fails, you are certain that this guy here is going to catch the bad behavior in the code. Now, if there is a way for me to recover from this particular kind of issue I have caused here, I can write code here to do the recovery. But in this case, it's just a demonstration to show you how you can do some bad stuff, and it's going to result in one of the interrupt service routines being invoked. All right, and if you look at the left side here, it tells you the function calls that led there. So it was in main, I did something, and that thing I did has triggered the HardFault handler. Again, this is not about debugging. We will have a dedicated episode on debugging, but I hope I have been able to convince you on how the vector table works and how interrupts are handled, and how you can even trigger an interrupt unknowingly with a bad code, or even knowingly if you have a strategy for recovering from it. Thank you very much for watching this, and I will see you in the next video.